Have you ever just stopped and looked around at the sheer, mind-blowing variety of life on this planet? You've got lions, you've got snakes, you've got us. It's this incredible empire of life in millions and millions of different forms. But here's the wildest part. Every single bit of it, all of it, started from one single point. So that brings us to the big question, right? If it all kicked off with just one tiny cell, why isn't life just, one thing? How did we get this spectacular explosion of diversity we see today? All right, let's dive in and trace this story all the way back to the very beginning. Okay, so our journey begins on a very, very early Earth, and I want you to forget everything you know about our planet. No green fields, no blue skies. We're talking about a chaotic, fiery world where the stage was being set for the greatest story ever told. Now, just look at the timeline here. The scale is almost impossible to wrap your head around. For hundreds of millions of years, Earth was just this ball of lava. Then these cosmic deliveries, asteroids and comets, start dropping off water, cooling the planet down into this massive chemical soup. It was like a planet-sized chemistry experiment. And when lightning zapped that soup, it provided the energy for chemicals to form the first genetic material. An oily layer formed around it to keep it safe, and just like that, 3.5 billion years ago, life had its first tiny foothold. So this first little cell, floating around in this ancient ocean, then did something absolutely miraculous. It followed its new genetic instructions, and it made a perfect copy of itself. This was it. This was the moment life learned its most important rule. Make more life. Now for the next 2 billion years, and let that sink in, 2 billion years. That's almost half of Earth's history. Life was just these simple, single cells copying themselves. But then, a complete accident happened. An accident that would change the course of history and unleash the power of complexity. And this slide just shows that moment perfectly. It was so simple. 2 cells just bumped into each other. But instead of bouncing off, they fused together. Their genetic blueprints combined, creating a brand new, more complex kind of cell. And here's the most important part. This new souped-up cell could also copy itself, passing on all that extra complexity to every generation that came after. And this is where the real fun begins. This new line of complex cells started copying, but the copies weren't always perfect. With each replication, tiny errors, mutations would pop up. Think of it like making a photocopy of a photocopy. But in evolution, these mistakes are where the magic happens. They create new possibilities. Over millions of years, this constant tinkering created this incredible explosion of life, filling the oceans with all kinds of new creatures. Now, out of all this amazing diversity, one lineage in particular is going to lead directly to us. And our ancestor at this point, it wasn't some kind of monkey or ape. It was this, a simple 3-inch-long waterworm. And it was about to face a problem that would lead to one of life's most amazing inventions. Yeah, take a good look. This humble little creature, swimming in the dark oceans 550 million years ago, that was us. By now, male and female genders had evolved, so the mission was pretty simple. Find a partner, reproduce, and keep the species going. But there was one huge problem. How do you do any of that in a world of total darkness? With no way to see, finding a meal, spotting something that wants to eat you, or finding a mate was just a game of chance. Survival was on a razor's edge. Life needed a new tool. And what an answer! It started out so simply. Just a few skin cells on our wormy ancestor mutated and became sensitive to light. That tiny little advantage was a full-on revolution. Suddenly, our ancestors could tell the difference between light and shadow. They could find food, and just as important, they could find each other. The world wasn't completely black anymore. But seeing the world is one thing. You have to understand what you're seeing. All this new visual info needed a processor. So the nerves right behind these new eyes started to clump together. This cluster, which first showed up in an armored fish about 521 million years ago, that was the very first primitive brain. It started small, just to make sense of light and dark, but it would end up becoming the most complex object we know of. So, with the power of sight and thought, our ancestors were thriving. But the thing about the environment is, it's always changing. And the next huge challenge was brewing right there in the water they called home, forcing another massive jump in our story. So here was the deal. The problem was simple, and it was deadly. The oceans were running low on oxygen, which is life's fuel, And at the same time, toxic carbon dioxide levels were going up. Our fish ancestors were basically suffocating. The drive to survive was absolute. They had to find oxygen somewhere.
So they did something incredibly risky. Our ancestors, these armored fish, started swimming up to the surface to gulp air. And over countless generations, this desperate act led to another amazing evolution. Their bodies developed a new way to hold that precious air, the very first lungs.
And meet Ichthyostega. This creature is just a perfect snapshot of evolution in action. 365 million years ago, it was the perfect bridge between water and land. It still had its gills for breathing underwater, but it also had working lungs to breathe air. This was the animal that, for the first time in our family tree, poked its head out of the water and saw a whole new world, the land. That first look at land must have been incredible. A whole new home, free from the suffocating water. But taking that first step onto solid ground was a huge deal, and it came with a completely new set of rules for survival. And by 340 million years ago, our ancestors had adapted. Their skin, which would have been burned by the sun, got tough and scaly. Their fins evolved into legs with claws, strong enough to walk on the ground. We had become these reptile-like creatures, ready to take on this new world. But one last chain still tied us to the past. I mean, think about it. We could breathe the air, we could walk on the land, but just like frogs today, we still needed to lay our eggs in the water. How could our ancestors ever truly leave the ocean behind if they had to keep going back for the most important part of their lives? This was the final hurdle, and to solve it, nature was about to invent something so perfect, so revolutionary, that it would finally cut the cord to the ocean and unlock the full potential of life on land. And that's exactly what it was. This next innovation wasn't just another small step. It was a masterpiece of biological engineering that changed everything. The amniotic egg. It was basically a personal ocean for the baby embryo. It had its own protective hard shell, its own packed lunch, the yolk, and its own water supply. For the first time ever, a creature could lay its young on dry land, completely free from the water. It was the key that unlocked the continents. And with that, the journey was complete. From a single cell in a chemical soup to a complex reptile stepping onto dry land, able to breathe, walk, and have babies far from the shore, the planet was now wide open. But as our ancestors started to spread out, they were not alone. A new world was won, but the race to rule it had just started. What massive creatures would rise up to dominate this new landscape? And what part would our own tiny ancestors play in the epic story that was about to unfold?